Hi guys, welcome back to Waka Code. And now here in this video we'll see some problems on increment and decrement, pre-increment and post increment, and also pre-decrement and post decrement. See, first question is this: a given a equal to 10, b equal to 2, and a plus plus. I have said that what is a plus plus now? 10 and plus 1 is hanging around in here, and when the compiler says a again, the plus 1 is added to a, and now minus minus b, it is pre-decrement, so here the entire value becomes 1 because b is 2. So here what is a plus b? If we write a plus b in the output, or whatever it is, if you want to write like c out a plus b, then the compiler has seen a again, so it plus 1 is added to 10. So here the a value is 11, b value is 1. What is a plus b now? 12. 12 is the answer for first one. Second one, given a equal to b equal to 4, minus minus a. This is pre-decrement. What is pre-decrement here? In pre-decrement, 1 is deducted directly from a, and this whole value becomes 1. And when in post increment, this is post increment. In post, what happens, what is now a value? 1. It is not 2 because it is pre-decremented. So here the value is 1 and plus 1 is hanging around in here. When the compiler sees again a, it plus 1 is added to a. Next, b minus minus. What is b post decrement? Means the b value is 4 and minus 1 is hanging around in here. When the compiler sees b again, it decrements 1 from 4. Then minus minus b. Here the compiler saw b again, so the value becomes 3. This is pre-decrement, so the value becomes 2. Did you get that? See, I'll explain it once again. B minus minus and minus minus b. When b minus minus, this is post decrement. This means here the value will not be deducted directly. When the compiler see b again, then the value is deducted because 1 will be hanging around in here. If in post increment or decrement, 1 will be hanging around in here. If it is increment, when the compiler sees the variable again, it is incremented, or whether it is a decrement, or if it is a decrement, when the compiler sees the variable again, it decrements. So here the value of b is 4, and we are post decrementing, so 1 will be deducted. When the compiler sees again, 1 will be deducted. Here the compiler saw b again, so 1 will be deducted, that is 3. And minus minus, now minus minus 3, this is pre-decrement of 3, that is 2. So here the value becomes 2. Value of a is 2 because the compiler saw a again. See here, pre-decrement, when pre-decrement, value became 1. Now here the value is 1. If here the value is 1, then post increment, when the compiler see a again, 1 will be added to this existing one. So the compiler saw here a again, so a value of a is 2, and when value of b is 2, so the output will be 4. Next, see here the place is some congested, try to adjust that. We'll cover this problem in next problem also. C, here C, the value of C is 12, the value of D is 0. Minus minus C, that means it is pre-decrementing. What is pre-decrementing? Here, if the pre-decrementing, here the value is deducted directly, no hanging around in air, that is 11. D plus plus, this is post incrementing. 1 will be incremented when the compiler see D again. Okay, now 0 and 1 is hanging around in air. The value of D is 0. Here the entire value is 0. 1 will be hanging around in here. Here C, the value of C is 11 and minus D. The compiler saw D again, so 1 will be added and 1. The output is 10. Don't worry, we'll write code for these problems also. Once we'll explain, that's it. Here in the fourth problem, the value of A is 1, given as 1, B is 0, B is 0, and minus minus A, pre-decrementing A, so the value becomes 0 directly, and pre-decrementing B, the value becomes minus 1, and post incrementing B, post incrementing b -1 plus 1 will be hanging around in here, and pre incrementing b. See, focus on here, plus b. Here the value of b is 0 now. See, -1 is there and +1 is hanging around in here because we have post incremented this. When the compiler see b again, 1 will be added to the existing value. The existing value is -1 here, and +1 is hanging around in here due to post increment. And when we give again pre increment, +1 will be added to the b, and now the compiler saw b again, so +1 will be added to this -1 and becomes 0, and now this +1 is added to 0, and this whole value becomes 1, and now a equal to 0, b equal to 1. What is a plus b now? 1. I think you have understood this. Now a equal to 0, b equal to 10, equal to 0, b equal to 10. Pre-decrementing a. See, this type of problems is important to understand this concept. Okay, yeah, you feel some confusing, but you feel confused, but this is the correct way to conquer this increment or decrement. Pre-decrementing a, here pre-decrementing a, what is a value? 0. Pre-decrementing means the 1 is directly deducted here, no hanging around in air. Pre-decrement or pre-increment, no hanging of 1 in air, so the one is directly decremented from this 0 minus 1 of 0. How much? -1. And now post incrementing, here the value of a is 1 -1, the value of a is -1 and +1 is hanging around in here. Okay, did you get that? The value of a is -1. How we get that? How we got that? Because here the value became -1, so the value of a is -1 now, and we are increasing by +1. When the compiler sees a again, 1 will be incremented to it. See, we are asking this, the compiler saw a again, so 1 -1 +1 will be added to -1, that is 0 into b. What is the value of b? 10. 0 into 10, how much? 0. Now let's see the code. Let's see the code. A equal to 10, b equal to 2, hash include IO stream using namespace std in main and 0. And now I'm giving int a equal to 10. I'm copying the first problem. The next int b equal to 2. The next post incrementing a and pre-decrementing b and a plus b. Directly I will see out a plus b, and then we are using inline function because I wanted to write. I'm directly implementing all 5 codes here only. We'll get it we'll get it all 5 answers in the same output. That is why I'm using inline function to get the output in different line. The next a equal to a equal to 2. See, we can reassign a value. We can reassign a value to a, but we shouldn't redeclare a. What is redeclaration of a? Using data type. We should not mention data type of a again. It throws an error. Okay, a equal to, I'm reassigning a value. I'm reassigning value to a. This can be done. A equal to 2, b equal to 4. Then I'm pre-decrementing a and post incrementing A, then post incrementing B, post decrementing B, and pre decrementing B. What I've asked here, A plus B, right? C out A plus B in line. Next, this is the second problem. And third problem, what is the third problem? C equal to 2. See, int C equal to 12, because I've not used the C variable here. Okay, int C equal to 12, int D equal to 0, pre-decrementing C, post incrementing D, and what is C minus D? C out C minus D and line. Next, what is the fourth problem? A equal to 1, B equal to 0, A equal to 1, B equal to 0, pre-decrementing A and pre-decrementing B, then next post incrementing B, and then next pre-incrementing B. C out A plus B. What is the problem? A equal to 0, B equal to 10, A equal to 0, B equal to 10, minus minus A plus plus, C out A into B in L. Yeah, this is the code, and let's check it. Then int A equal to 0, int B equal to 2, okay, equal to int C equal to 12, int D equal to 0, C out. Yeah, I think there are no errors. Let's see the code. Let's see what is the output. 12 4 10 1 0. 12 4 10 1 0. Did we get that? 12 4 10 1 0. 12 4 10 1 0 is the output. Yeah, we have got 12. We have got 12 here. Okay, first one correct. Then 12 4, okay, 4 correct. 10, okay, 1, okay. Yeah, this is 0. See, this is 1, this is 0. We have got 12 4 10 1 0. You can try this, you can try anything. Go get your laptop and try A plus plus minus minus B, something rubbish. You'll get it. You'll try to practice on your own, you'll get it. And these are the problems, 5 problems. I think these are enough to understand increment and decrement. Yeah, in the next video we'll see